Hey, welcome. Today we are going to demo using Python to automate some tasks for us in ArcMap. All right, so the data we'll be working with is a land use raster representing land use throughout the entire province of Ontario for the year of 2010. Okay, you can see that we are zoomed in to the GTA, Hamilton, Mississauga, Guelph, Kitchener, Waterloo, Cambridge. Okay, but it actually extends across the entire province. We also have the shapes of all the municipality boundaries throughout the entire province, okay? And those are outlined here in the black. So our goal, our research question is, what was land use in 2010 for the city of Guelph? Now, we've actually already seen how to do this, answer that question, using the clip tool for rasters, okay? We can just click once or twice, pull up that menu, and clip our land use to the city of Guelph boundaries. That is in fact actually what we are going to implement in Python, okay? But you can imagine that if we wanted to do one of two things, that we would want to then use Python to automate them. So first, if we wanted to extract land use information, not just for Guelph, but for every city in the province, if we wanted to extract that into individual layers where we can say, okay, this is Guelph's land use, this is Waterloo's, this is Cambridge's, so on and so forth. If we wanted to do that, we would want to use Python because there are hundreds of municipalities throughout the province. And if we had to clip each one, that would take a lot of clicking. We would have to go to the clip data management menu hundreds of times to create separate layers representing each city's land use. In Python, we can do that in a matter of lines, okay, and let the computer do the work for us. You can also imagine that if we had more than one land use layer, we had 2010, but also 2000, 1990, 1980. Even if we just wanted to look at Guelph's land use in all those years, we would still need to run clip 4 times. Instead, again, using Python, we can do that in a number of lines. A click of one button rather than having to click several times and pull up the menu several times. So let's go ahead and get started and look at how to do that. All right. So we are going to open our Python menu in the geoprocessing menu. Okay, there's also a button here that allows us to directly access it, but we can just use the geoprocessing menu here. Okay. And we're prompted to enter some script, some code. Okay. Now I've already typed out everything we need. Okay. And in fact, you will be using this code for lab 5. I'm going to go ahead and copy and paste it in to make sure we get it right. So I put it into a text editor. Whoop. And we are going to just copy and paste it in. So the first piece of information we need, we're going to tell Python to access our layer representing the different municipalities throughout the province. Okay, so we are creating a variable called list of cities. We are telling Python to just load this up, to get a hold of it and to store it so that we can work with it later. Okay, so we press enter and it's asking us for another line of code, so that's a good sign. All right, what we're going to do to start is just print out the names of each of these cities. Okay, we're going to do that using a loop. Okay, so the first part of our loop is going to set it up. So we're going to say for every city in our list of cities, so for every row in our data, for every city we have, we press enter and it asks us for the next piece of code, what we actually want to do with each city. Okay, notice the indent. Indentation is important in the Python programming language. It automatically indents for us. We are going to say print the legal name of this city. Okay, so we've called the print command, and we are saying print the legal name of the city. So you can think about it this way. The city is just a row in our data, in our municipal boundaries layer. Okay, we're going through each row and printing the legal name. This legal name is just the name of the column that stores the legal name of the city. So this is a column, this is a row, and we are saying print the value of the row at this column. Okay, and we do that using this period. We say access the value at this column and at this row. Okay, so we go ahead and press enter twice, and it's going to start printing that out. Okay, it's not literally printing to any sort of printer or anything, it is printing to the window. Now you can see there are a lot of municipalities across the province, so this is actually going to take some time. You can imagine that if we wanted to clip that land use layer to each of these, that would take a lot of time by hand. Instead, using Python, we can loop through each of them and perform different functions. Now we're just printing the names of the cities now. What we'll see in just a second is how we actually would clip that raster data. All right, so that's finished. Now we are going to go ahead and do that clip. Now we're only going to do it for Guelph, okay? But again, we could do it for multiple cities if we wanted to. So the first thing we need to do is to actually reload our list of cities. For technical reasons, we just need to load it up again, say Python, hey, get a hold of those cities that in our layer and be prepared to work with them. So we do that. The next thing we need to do is to tell Python a little bit about how to access that information. Okay, so here our line of code is essentially saying find the name of the column or field in our cities layer that is storing the geometry or the spatial data for our cities, okay? Because we are, essentially what we're doing is we're trying to pull out, for Guelph only, that boundary so that we can cookie cut out land use at that boundary, okay? So we are asking for the name of the field that is storing the geometry information or the shape information in this, for every city in this layer. Now we are eventually going to only want Guelph, but we're just saying we need the name of that column. Okay, so we press that and we're storing that information. Next, we're going to build up our loop again so that we can go through each city, find Guelph, and perform our clip. Okay, so same thing again for every city in our list of cities, do something. Now we'll go ahead and print the legal name of that city again, just so that we know where we are. But we're also going to say that if the legal name that we come across is the city of Guelph is equal to the city of Guelph, perform some other function. Now what we are going to do first is to get that geometry, get that spatial information, so that Python has a hold of it and can act with it. Okay, so what we're saying here is store within this variable called city shape that spatial information. We have our row, which is just the city, and we are saying get the value in this row at this column. Remember, this shape name is just the variable storing the name of the column that has the geometry in our layer. Okay, so we were just saying get the geometry based on this column and for this row. So we press enter, but we're not done yet. We have the geometry, we have the cookie cutter, but now we need to actually perform the clip. Again, you know how to do this by hand using the different menus in ArcMap. We're going to see how to do it in Python so that we could automate it if we wanted to, and do this for many cities or even for many land use layers, years of land use. So we'll paste that in. So we are saying Python, use the clip tool in the data management part of the toolbox to do the following things. And what comes after or in between the parentheses, that's just the different parameters or variables you have for this analysis or for this function. They correspond to all those different options in the menu that you would see if you did this clip by hand. So our input raster, our in raster, is going to be the 2010 land use layer. We don't need a bounding rectangle because we're going to actually use our Guelph shape for the clip. We'll name our output raster Guelph Clip 2010. Our input template or data set is going to be the city shape variable we just created, because that's what's storing the shape of just the city of Guelph. That is our cookie cutter. Okay, and then some other options here that are important. Okay, our clipping geometry, this just tells Arc that we want to use the geometry that we've loaded as the city shape. So that we are using Guelph as our cookie cutter. And then we also just want to make sure that we are maintaining the extent of our data within the boundaries of Guelph. Okay, so these are just options that are important to include. We don't need to alter them at all, but we need to include them in our function. And finally, since we only want to do this right now, at least for the city of Guelph, we need to tell Python that after it's done all this, that it can go ahead and call it quits. You don't need to go through all the rest of the cities. Once we found Guelph, we can break it off. Okay, so we will say break. Take a break. All right, so then we shall hit enter twice and it'll start us off again. So we are again going through each of the cities in our layer, each of our cities in that municipalities layer, which we have stored in that list of cities in Python. And Guelph is somewhere in the middle, so it's going to take a while to get there because it's going through in the order that it's just in the data. Okay. And we run into this error because what has happened here is that we have already created this file, and Python doesn't, it's not going to overwrite it. Okay? This is an easy problem to solve. You might run into it yourself. Let's see how to fix it. First thing we need to do we just need to reload our list of cities. Okay, so we just need to reload it so that we can loop through them again. The next thing we need to do is just call up the script we ran just now that went through each one, each city, looked for Guelph, and then tried to do the clip. All we need to do is change the name of the raster. So we'll just call it Guelph Clip 2010A. All right. So then we'll run it again. Again, we're going through all of the cities, looking for Guelph, and then we will clip our data. We found Guelph, it's stopped, it's clipping down here, and it produces our new layer here. So let's close out of Python. We're done with it for the time being. And see what we have. As you can see, we've produced a new layer that represents land use only within the city of Guelph. Okay, so we've just pulled out all those raster cells from the original land use 2010 layer. We've pulled out only the ones that fit within the boundaries of the city of Guelph.